Okay, now we will study about vectors. What is vector? Vector is having both magnitude and direction. O a vector. It has magnitude and direction. That is a vector. So what is vector? Denoted by the symbol vector. This vector is denoted by a common bar. This is vector A. This is vector A. Vector A. So when you add two vectors, vector A plus vector B, how you will add? Vector as a direction. So that is vector A plus vector B. Vector has a direction. So how will you add vector? We will see if AB is a vector, EB is a vector, and its magnitude is A, then BC is another vector, its magnitude is B. Magnitude is B. Then vector B, AC will be the vector. So vector AB plus vector BC, that is equal to vector AC. That is equal to vector AC. So like this you can add vectors. Subtraction also we can do the same way. For subtraction, see that vector AB, if this is a vector AB, this is vector, same vector. If it is AB, same vector, then magnitude is same, then this will be minus AB. Vector minus AB, this will be vector AB. This will be vector minus AB. So vector minus AB, opposite direction. Opposite direction means it is minus AB. Okay. And also, we can see then force or in electrical circuits. If a vector is in this direction, it has got two components. Two components for a vector. If it is a vector F, it's an angle theta. Then, if you draw like this, suppose this is a vector. Okay. Now, let me draw again so that you can easily understand. Let me draw O. This is one vector. This is another vector. Okay. Now this is the force. Now force can be split up into vertical component. This is horizontal component. And this is vertical component. See, this is vertical component. If angle is theta, then again distance is required here. Okay. Because F. Here F you can draw here also. Like this, okay. We draw from here. What will happen? What is, if it is a point O, it is a point A. Okay. Now OA equal to, I am getting OA by OF equal to cos theta, and AF by AF is opposite side. This seems to be a this is perpendicular. Okay. Now AF by OF is equal to sin theta. So you can write OA is a component, horizontal component is equal to OF is as F cos theta, and AF is equal to F sin theta. So you can divide into two components, F cos theta and F sin theta. Okay. So this is fundamental principles of vector. Now vector addition I thought, and vector subtraction also can do. Now we go to dot product of vector. Dot product. What is dot product? If AB is a vector and CD is another vector, then AB dot CD is called the dot product of vector, and that is equal to AB dot CD equal to A is magnitude. If AB's magnitude is A and CD's magnitude is B. AB cos theta. AB cos theta n. N is a unit vector. You can try n also, you can try, but n is not required. Is a unit vector. Unit vector means vector having magnitude is 1. Okay. AB cos theta. ABCD is AB cos theta. This is called the dot product of vector. Dot product. If two lines are perpendicular. If two lines are perpendicular. Suppose two lines. It is OA, OB. See, two lines are perpendicular. Then this product. It is cos angle theta is 90. Cos theta is cos 90. 0. This dot product is 0. So perpendicular lines have dot product 0. That is OA dot OB is equal to 0. 0. Dot product is 0. Now we see what is a position vector. Position vector. Position vector means, let us go to a coordinate system here. If OA is a vector and its points are, let it be 4, 6. Let it be 4, 6. Then what means it is along the x-axis it is 4, along the y-axis it is 6. Okay, now the position vector we can write OA based on a Cartesian system. OA is equal to, we can tell, vector can be represented this way also, or it can represent simply OA. Okay, equal to, what is OA? We know this direction is called I, and this direction is called J. J, unit vector along X, unit vector along Y. So this you can write 4I. Vector representation is 4I plus 6J. So this is a vectorial representation. Vectorial representation of 4I plus 6J. And this magnitude of OA is equal to square root of 4 square plus 6 square, that is 16 plus 36. That is equal to 52. So magnitude is like that. So we can write vector with a magnitude and its direction so a. You can tell it's an R. It's a vector R. You can see R is equal to this. Okay. Now. Let us see unit vector. The vector unit vector is meant by this equal to vector divided by modulus of a vector. This is a modulus of a vector. Modulus of a vector. Modulus of vector. Modulus of A is equal to A. Modulus of A is A. Length of vector. And this is a vector. So A is value, then yes, length of vector. Then modulus of vector equal to modulus of vector over A. This modulus of vector over A is modulus of vector is equal to A. Length of vector. So now unit vector is vector to the divided by modulus of vector. Two times A means if A is here, A is a vector, then 2A is also a vector. This value is 2A. So B. It's a parallel vector. A, this value is 2A, but it's a parallel vector. Parallel to 2A is a parallel vector. So it becomes modulus of M A equal to modulus of M into modulus of A. Modulus of A. M times that of A. M times that of A. M times that of A. That of A. Very difficult to know modulus of vector. PQ is a vector which is equal to position vector of Q minus position vector of QP. Okay. Let's take 2 points here. One is here, OP, another is here, OQ. OQ. Numeric question vector of P, OP. Question vector of P, OP. Then, what is question vector of Q? OQ. Now, what is PQ? PQ is from here, you know. Okay, now we see the question vector of PQ. What is? Okay, now we see the question vector of Q, OQ. Question vector of OP. Question vector of P, OP. Now, PQ is equal to, you can say equal to PO. Vector PO plus vector OQ. You can see in the diagram. In the diagram you can see it is PO. So PO means it is coming in this direction. PO. So if it is A, you consider this as A. OP equal to A. OQ is equal to B. Let us consider. Then PO means it is minus A. Vector is pointing this way. Minus A. OQ. That is PQ. PQ means it is a vector. If you take it as a vector like this, it comes by addition of A plus B. So minus A, this is minus A plus B. This is A. This direction is A. This direction is minus A. So minus A plus B. Or that is equal to B minus A. That is, B means the position vector of Q. Position vector of Q minus position vector of P. So you can tell it as PQ is equal to position vector of Q minus OP. You can tell OQ minus OP. Can tell it as OQ minus OP. Okay. Okay, in the example B saw that the force is acting here. It has two components. I told earlier, but this is called OA. Is called the projection of the vector OF on x-axis. OA is called the projection of vector. Projection of vector OF. Vector OF means this F on x-axis. Remember, this is a projection of vector. OA means the projection of this vector on x-axis. See now this is force acting on the plane at an angle theta, and this let it be OA. Then OA is called a projection of line OF on x-axis, on and OF on x-axis. That is equal to f cos theta. F cos theta. Next points. Collinear vectors. If A vectors A and B are collinear, they resist a scalar between that. A should be equal to lambda B. Yes, collinear A is equal to lambda B. Now we see parallel vectors. The condition for parallel vector is, let us take a vector A is equal to A1i plus A2j plus A3k, and B is equal to A1i plus A2j plus A3k, C is equal to C1i plus C2j plus C3k. By the way, what is ijk? Let us see what is ijk. Ijk are unit vectors along x, y, z directions. We take the y, repeat the analysis here like this. Okay. So how will you draw this? This is x axis, y axis and z axis. Unit vector along this is ix, along this is iy, along this is ik. Second so unit vector is ijk are this, and is also understand I into I is equal to 1. J into J equal to 1. K into K equal to 1. I into J equal to 0. I into K equal to 0. J into K equal to 0. J into J into K is equal to 0, and K into J is also 0. K into J is 0, or J into I is 0. Remember, if it is opposite way like this, everything will be 0. If it is same, it will be I into I and J into I. Now we see what is parallel vectors. If these vectors are parallel, condition for the vectors parallel is to be parallel A1 by B1 equal to A2 by B2 equal to A3 by B3. Condition is A1 by B1 equal to A2 by B2 equal to A1 is the coefficient of I, A2 is coefficient of J, A3 is coefficient of K. B1 is coefficient of I as well. These coefficients of A1 B1 equal to A2 by B2 equal to A3 by B3. So this is the condition for parallel vectors to be parallel. Okay. Note taking C1. Only taking A and B. A and B. Okay. So condition for parallel measure A1 by V1 is 2 by V2 is 3.